Welcome to EDU World Space.
Okay, in this problem we have a mirror, a spherical mirror of some kind, with a focal length f that we know, and a magnification m that we know. So for part A, we're asked to show that the object distance is equal to the focal length times 1 minus 1 over m, this expression. And then we're asked to demonstrate for a convex mirror that the magnification is always between 0 and 1. So to start out, we're going to be making use of two things. One, the definition of magnification. Yes, it's the ratio of heights for the image and object, respectively, but it's also the negative ratio of distances for the image and object. So we make use of that. We're also going to use the ideal lens equation. 1 over f is equal to 1 over d naught, or do rather, plus 1 over di. Make use of these two things. So it starts off for part A. Take our definition of m, which is equal to negative di over do, which gives us an expression for di in terms of the other quantities that we know. It's negative m do. And then combining that with the lens equation that I just showed, we can get 1 over f equals 1 over do. And we can take our di that we derived just now to give us negative 1 over m do. And thus, just one more step of algebra, we get, let's show it in its entirety. 1 over f equals 1 over do, 1 minus 1 over m, which is what we want to show. Now for the second part, we set the object distance equal to the range of all positive numbers. Since the focal length of a convex lens is always negative, the term with parentheses in this above equation that we just derived must be in the range of all negative numbers for the object distance to include the range of all positive numbers. So just to quantify what I just said there, 1 minus 1 over m is always less than 0. Thus, 1 is always less than 1 over m. Thus, m is between 0 and 1. So that's really the evidence they need, the proof that we need. So just to recap, we use the definition of m and the lens equation to get this expression. And then we just looked at this expression for values when f, for a convex lens, when f is going to be negative, these things must follow. And that's it.